this welcome back. In this video I'm going to help you to solve the problems from the notes of Newton's law. Well, first of all, you have to be sure that you understand the note, what they say. The first law, it says if the total force is zero, the velocity will be constant, or the momentum will be constant, the mv will be constant. The second law says that the sum of all the forces is mass by acceleration. So please look this deduction, what it means. Acceleration means change in velocity per unit of time. And the third law says the action and reaction. I have explained these three laws in previous videos, so I hope you have no problem at all. So let's go directly to solve the problems. And also please see the third law is a new interpretation of the third law. If the force acting on 1 due to 2 is minus the force acting on 2 due to 1, this is the relation. The force acting on 1 is the mass of 1 by the change in velocity of 1, equal minus the force acting on 2 is the mass of 2 by the change in the velocity of 2. If you cancel delta t, etc., you will find the momentum conservation. So what it means is that the third law, F12 equal minus F21, the force acting on 1 due to 2 equal minus the same magnitude but in the different direction, in the opposite direction. This law, it takes you directly to one very important conservation of one very important law, that is the conservation of momentum, that will say that the final momentum is equal to the initial momentum. The total momentum final equal the initial momentum. Okay, so the problems that this is why we came here. We came here to solve this problem. For example, imagine that you have a small rope like this one. The small rope maybe is attached to another rope, and it produces a tension T1 on this mass M. This is the mass of the small rope. So there is tension T1 on the rope going up, and maybe the rope is also attached to the floor, so it's a stretch. Okay, so there is tension T2 acting on the rope. So there is one tension T1, one tension T2. How you will apply Newton's law? The sum of all the forces equal the mass by the acceleration. You will say, okay, if this is the situation, and this mass, the mass of the body is not accelerating, let's say that is not accelerating, but even if it's accelerating, you can suppose that there is an acceleration going upward, for example. So how you will apply Newton's law? You will say the sum of all the forces equal the mass by the acceleration. How many forces are acting on the mass M? Is the tension T1? Is the tension T2 going downwards? So T1 positive, T2 negative, because I have chosen the positive direction. You choose it always in the same direction as the acceleration. But even if you choose it in the opposite direction, nothing will happen. It's only that the result will be the opposite, the negative of the result. Okay, so and there is another force here, that is the weight, mg, of the rope. So the equation will say T1 going up minus T2 going downwards minus mg equal ma. In the case that A is 0, if A is 0, the equation will be T1 minus mg minus T2 equals 0. And in the case that the rope have mass 0, so this rope have a very, very light mass, T1 minus 0 minus T2 equals 0, and you get to the conclusion that T1 equals T2. So for ropes that they say they are very light, this T1, the magnitude of T1 is equal to the magnitude of T2. This is the first example. Now, the second problem is exactly the same thing. We see an object. The object has mass m. The object is with acceleration to the right. If there is acceleration to the right, it's because there are more force to the right than to the left. No way. So the sum of all the forces equal the mass of the object, capital M, by the acceleration of the object. So in this problem, all the forces are on the x direction. So there is a force T1 positive, this one, positive, and a force T2 going in the negative direction, minus T2. So the sum of all the forces, this is the sum of all the forces, because there are not any other forces acting on the body. The weight is not acting on the x direction, the weight is in the y direction, so the weight is not, in this problem, is not being involved, because it is supposed also that you may think that there is a floor here, so the weight is cancelled with the normal force. You may think like this. But imagine in space, you have the object in space, the object is accelerating in this direction. So there are more force T1 than T2. Is the only way that the mass can accelerate. And the sum of all the forces is the mass by the acceleration. Okay, so in this case, what it says, this is not a rope, this is an object of mass different than zero. Its mass is positive. So what it says, this problem is that T1 is equal T2 plus MA. What it says is that T1 is bigger than T2 in the amount of MA. So the amount of tensions that is to the right is equal to the amount of tension that is going to the left, T2, the amount plus MA. So T1 is bigger than T2. Okay. So the fact that T1 is bigger than T2 is the fact that makes possible that the acceleration of the body is going to the right, is going to the direction where there is more force. Okay. Okay, now we are going to discuss this problem. The problem is a problem that involves no acceleration. So the acceleration is zero because the body is in a state that we name equilibrium. Equilibrium means acceleration zero. So the sum of all the forces are zero. Now this sum of forces can be interpreted like the sum of all the forces in the x direction and the sum of all the forces in the y direction. They are zero because if the total vector force, the sum of the is zero, is because there are the sum on the x direction is zero, and the sum of the y direction is zero. So we have to apply Newton's law to this problem. Indeed, the problem is more a problem about vectors than about Newton's law. The only subtle question that is here is to what point we will apply the sum of all the forces equals zero. Well, we can apply the sum of all the forces equals zero to the mass m. If we apply to the mass m the sum of all the forces, we will conclude that there is a force pulling down, mg. There is a force going up, and unknown force. T3 we call this force. And the sum of all the forces should be zero, otherwise the mass will be accelerated downwards or upwards. The sum have to be zero. So if I choose the positive direction going upwards, I would write this equation: T3 going up plus T3 minus mg equal m by a. But because a is 0, m by a is 0, not because m is 0, it's because the acceleration a is 0, because I'm dealing with a static problem, a problem with equilibrium. So T3 equal mg. Now it comes the following part. T3 is the force that is acting here. Here. What is the force on this point P? On the point P, on this point P. The force, this is the rope. I have proved in the previous examples that on the rope, if T3 is the force that the rope is doing on the mass m, there is another force, T3 prime, going downwards. That is the reaction. And I have proved that if the mass is 0, also T3 have to be go upward. So now this is the force acting on the rope, but I want this force, the force acting on the point. So on the point P, we will have the force T3 going downwards, but T3 is mg, is the weight that was holding. I have T1 or T2, let me see, T2. I have this angle theta, and I have T1. I might have to impose the condition now to this example that the sum of all the forces in the x direction equals 0, and the sum of all the forces in the y direction equals 0. So it's now a problem more on vectors. What is the x component of T2? I see, if I go to place this equation, the x component of T2 is T2 cosine of theta 2. This is theta 2. What is the x component of T1, of this force? Is T1 cosine of theta 1, because it's going in the negative direction. So this is the sum of all the forces in the x direction, correct? And what is the sum of all the forces? Is equal to the mass by the acceleration, but the acceleration is 0. So for the x direction, I have produced one equation. That is T2 cosine of theta 2 minus equal T1 cosine of theta 1. Now let's go to do it in the y direction. In the y direction, on the point, I see mg, T3, that have the value mg going downwards. I see T2, but the T2 that is going, the component y of T2 is this one. And this one is T2 sine of theta 2. Sine of theta 2. And there is another force that is T1 sine of theta 1. So I have mg going downwards. T1, if I choose the positive direction going downwards, well, mg is going downwards. T1 sine of theta 1 going in the negative direction, going upward, because I chose it like this, minus T2 sine of theta 2. And the sum, and this is the sum for the forces in the y direction. Well, and what is the sum of all the forces in the y direction? Is the mass by the acceleration in the y direction. But because the acceleration is 0, this is 0. Perfect. So I have equation 1 and equation 2. Equation 1 is the sum of all the forces in the x direction. The sum of all the forces in the x direction is T2 cosine of theta 2 minus T1 cosine of theta 1 equals 0. And the second equation is the sum of all the forces in the y direction. What is mg minus t1 sine theta 1 minus t2 sine of theta 2. So equals 0. So I have two equations with two unknowns. What is the two unknowns? T1 and T2. Because theta 1 and theta 2 are known, and the weight mg are known. So I have to solve this system of equations. Theta 1, and the solution is been here for an angle of an angle theta 1 is 10, theta 2 is 30. So these are the two equations. You solve the two equations by the method that you prefer, probably substitutions. So we solve for T2 here. We solve on the second equation, on the equation for the x for T2, and we replace the value of T2 on the y equations. We solve for T1, and this is T1. So you can check it. Let's go, and you can check it and do it. Let's go now to discuss the elevator. A man of 80 kilograms is at elevator. He stands on a weight scale. Find the measure of the weight scale if the elevator is moving up. Okay, this is the elevator. This is the elevator. This is the elevator. And the guy is here. And the elevator is moving with velocity constants. So it means that the acceleration is 0. So what Newton say? The scale is here. Here is the scale. We are going to measure the normal. So this is the force that the scale is doing on the guy. So the guy is here. The guy is subject to forces. What are the forces that are acting on the guy? Well, the scale is doing a force N. And the weight is doing, the earth is doing a force on the guy, mg. And the sum of all the forces is mass by acceleration. But in this case, the acceleration of the elevator is 0 because it's running with velocity constants. So the guy who is inside the elevator is running also at constant velocity. So his acceleration, the acceleration of the person, is 0 also. So what is the sum of the forces? The sum of the forces is the normal going up, positive, because we choose the positive direction going up, minus mg, negative, equal the mass of the person. The mass of the person, we are applying Newton's law to the person, not to the elevator. The person, the mass of the person by the acceleration of the person. But the acceleration of the person is 0. So the normal force equal mg. So the scale will measure the normal force. And the scale, the normal force will be exactly the same at mg. So when he's moving up, the normal force is mg. When he's moving down, the normal force is mg. When I will do only moving up 4 meters per second square. If now he's moving with acceleration, now things will change. Why things will change? Because now there is a net force on the guy. So I'm supposing that this is the elevator. The elevator is moving with acceleration at 4 meters per second square. Am I supposing that the guy is also moving with acceleration 4 meters per second square? So I will apply Newton's law to the guy, not to the elevator, to the guy. And the guy is subject to two forces. First force, the weight, mg. Second force, the normal force. The scale is making a force going up. Otherwise, how can he accelerate it with 4 meters per second square up? Because there is a force going up. that makes the acceleration, and this force has to be bigger than mg, otherwise he will not accelerate it upwards. So the normal force, the total force is the normal force plus the weight mg. The normal force plus the weight is this force. And this force has to go up in the same direction as the acceleration. So once that we realize that the normal force, the value of the normal force has to be bigger than the value of the mg, once that we realize that, we apply Newton's law and we say, let's go to choose the positive direction as the same direction as the acceleration, going upward. So what are the forces? I see the normal force N going upwards, plus N. I see the mg going downwards. And this is the total force. So this is mass by acceleration. Now, let's go to plug in numbers. The normal force, that is what we are looking, is mg plus ma. As you see, the normal force is not mg, it's mg plus something else, ma. So the normal force increase. What is the value? N equal 80 kilograms, I think, by g10 plus m80 by the acceleration 4. So this will be 800 plus 320, so it will be 1,120 newtons going up. So the normal force, the measure of the object in the first case was only 800, was mg. Now, in the first case of constant velocity was 800. Now the measure of the weights, of the apparent weight, of the normal force is 1,120 newtons going up. Please do it going downwards and see that the normal force will be smaller. Let's go to the next problem. Now, let's go to do this example 6. It's the mass 2 kilogram, the angle is 30 degrees. The force applied upwards in the direction of the inclined plane is 15 newtons. Find the parallel acceleration. Okay. So to find the parallel acceleration, we do more or less the same thing that we did before. Now, this is the inclined plane. This is the object. This is the object. Okay, this is the weight, mg, going downwards. If there is only this force applied, where there is the normal force going upward, the acceleration going downwards, going in the x prime direction, in this direction, the acceleration, the only one is the component of mg in this direction. So this is the force, this is the sum of all the forces in the x prime direction, is mg sine of theta. This is theta, so this is mg sine of theta. Perfect. So this is the force. But now the problem say that there is another force F going upwards. So this force. So if there is another force F. So let's go to apply Newton's law through the x prime axis. We take the positive x prime axis like this, x prime positive axis. So the sum of all the forces, well, no need to put vectors, on the x prime direction is the mass by the acceleration on the x prime direction. What is the sum? I see mg sine of theta, positive, going downwards. I took it the positive direction, going downwards, minus f, equal mass by the acceleration. So what is the acceleration parallel to the plane? The acceleration parallel to the plane, I have to divide by m, so it will be g sine of theta minus f. Perfect. We can plug in numbers. G is 10, sine of theta is 1/2. The force is 15 newtons, so the acceleration A will be 5 minus 15. 5 minus 15 is minus 10. So the acceleration is minus 10. What it makes minus 10? It means that the positive acceleration was going downwards. Positive acceleration was going downwards. So the acceleration is minus 15. It means that the acceleration is going in this direction, and the magnitude of the acceleration is 50 meters per second square. So, sorry, 10 meters per second square. 10 meters per second square. So this is the acceleration. Now it say, find the force that you need to apply in order to have zero acceleration. Okay, so I want to create a new condition of equilibrium where the acceleration is zero. So, so how I will do it? So I will say, okay, the force that is being applied is the 15 going up. So I have the body, I have 15 newtons going up. How many newtons I have going downwards? G sine of theta, 10 by 1/2. Sine of 30 is 1/2. So it's 5 newtons going downwards. 5 newtons going downwards. So in the total force that I have is 10 newtons going upwards. So if I want to create a situation of equilibriums, I need to put 10 newtons going downwards. 10 newtons going downwards will make zero acceleration. So let's go to do it in a mathematical form. The sum of all the forces through the x prime axis must be equal the mass by the acceleration. But now I want zero acceleration. So the mass by the acceleration, the product will be zero. What is the sum of all the forces? I have chosen the x prime direction, positive, going downwards in the inclined plane. So I have a plus 5 newtons going downwards, minus 15 newtons going upward, this force, minus 15 newtons going upward, and plus an unknown force that I don't know which one it will be, but the sum must be zero. So what force should be? So I will solve for F. 5 minus 15 is minus 10. Minus 10 plus F is 0. So the F is 10. 10 in the positive direction, so 10 goes downward. So this is the result, 10 newtons. This was the result. It's the same result. Okay, so this is the force that I have to add to the problem to create a condition of zero acceleration. Let's go to the next problem. Oh, I'm sorry, I realized that I made a mistake here. I'm sorry. If I divide by m here, F appears divided by m. So the 15 is 15 divided by m. So now the acceleration is wrong. The acceleration will be 10 divided by 2, 5, minus 15 divided by 2 minus 7.5 equal a. So the acceleration will be 5 minus 7.5 minus 2.5. So the acceleration is minus 2.5. I'm sorry, minus 2.5 meters per second square. So it means that the minus means because I have chosen the positive direction going downwards, it means that the acceleration A is 2.5 meters per second square minus 2.5, but going upward, going in this direction, Okay, now let me see if I made another mistake here. The sum of all the forces equal the mass by the acceleration. Forces going downwards is the mg cosine of theta, that is mg sine of theta, that is the 5, mg cosine of theta, so I made a mistake here. Let me correct. So the forces, let's go to do it. Let's go to redo it, I'm sorry, is mg sine of theta is going downwards the inclined plane in the positive direction of the x prime direction. minus, what is the force going upward? The force going downward is 15 newtons, minus 15 newtons, 15 newtons. And now I will add an unknown force, plus the unknown force that I have to apply to make this equal MA, but A should be 0, so to make this equal 0. So now I will plug in numbers. The mass is 2 kilograms. 2 by 10 is 20. 20 by 1/2, sine of 30 is 1/2. 20 by 1/2 is 10. So there are 10 newtons going downwards. This is the 10 newtons of the weight, of the component of the weight. Minus 15 plus F equals 0. So the F will be equal 15 minus 10. Okay, so the F will be 5. So I need to add 5 newtons, so it's the same result. Yes, here I didn't make the mistake. So the 5 newtons, I need to add it in a way that now I have at the end, I have 15 newtons going upwards from the initial force. The initial force is 15 newtons going upward, minus 15 newtons. 5 newtons now going downwards, and the mg sine of theta is 10. mg sine of theta is the 10 going downwards. So 10 and 5, 15 going downwards, 15 going upwards, acceleration 0. The sum of all the forces is 0, so the problem is correct now. Okay, I'm sorry that I didn't divide by m here. Okay, I thought m was 1 kilogram. I'm sorry. Okay, let's go to the next. Just reviewing what I did during the class. What I did, this is the case. I have chosen the positive direction where the weight mg is going downwards. This is on the direction of the inclined plane. Okay, this is the positive direction. mg sine of theta, yes, mg sine of theta, minus 15, the force is going upward, 2ax, so I found the acceleration, that is the value that they asked. It gave me minus 5 divided by 2, so the acceleration is going upward. Okay. So this is what I did in the class. So I realized the mistake because I saw what I did during the class. During the class, I didn't make the mistake. You see, the mass and my mg, I didn't make the mistake. No, I didn't make the mistake. So now let's go to. This is the important thing. When you see an inclined plane, the weight is here. The weight has a components going in the direction of the, going downwards in the direction of the inclined plane, of the floor of the inclined plane, of this floor. This is mg sine of theta, and this is mg cosine of theta. And of course, the force acting also is the normal force, whatever you add of the problem, any force that you add of the problem, you have to take it into account. But this is the good picture that you need to have in mind for solving problems, not to make the mistake. mg going downwards, vertically to the floor. This is mg cosine of theta. This is mg sine of theta. This is the force that accelerates the body downwards. And because sine of theta is smaller, the acceleration is smaller than g. Okay, let's go to this problem. This problem, I did it in class. I think that I did it clearly, but I'm going to review it. What I do is I apply Newton's law for each mass, m1 and m2, two masses. I consider the first mass m1, the forces applied to m1, the tension T, and the weight m1g. And I consider the positive direction like this. So I write the Newton's equation. Newton's equation say that T, the force going up, minus m1g minus m1g equal the mass by the acceleration. Of course, that if there is acceleration in this direction, is because the tension is bigger, is greater than the mg, of course. Otherwise, how it can accelerate upwards. So I do the same thing for the mass m2. For the mass m2, there are two forces acting on the mass m2. Let's go to make the picture of m2. This is m2. This is m2. There is the tension going upwards. The object is moving in this direction because m1 is moving upwards. So this object is moving downwards. So T and m2g, these are the two forces acting on the body. So there are two forces. m2g is positive, so I will do like this. Positive force, m2g, minus the tension. The sum of the forces equal the mass by the acceleration. Now, if I solve this system of two equations, I can find the unknown. What are the unknown? The unknown are the tension, that is the same in each body, because I have proved on the problem one that the tension, if it's a very light rope, the tension will be the same. So the tension is one unknown and the acceleration is the other unknown. How to solve the system of equations? So I think that I show you with detail during the class, but you can see here how I have solved the equation, and maybe, why not, maybe I could have done any mistake. Let's go to review if I have done any mistake. For the first equation, the tension is n1g plus n1a. So the tension is n1g. Oh, the tension is this. Okay, the unknown is T1, n1 is 10 and 100. Oh, what I did is I sum 1 plus 2. If I sum 1 plus 2, the first equation with the second equation, the tension will cancel. So the equation that I will have is m2g minus m1g equal, my sum, m1 plus m2. And this allow me easily to find the acceleration. So this is the acceleration. And to find the tension, I will plug in this acceleration into this equation, for example, into the first one. So T will be n1 by a plus n1 by g. So T will be n1 by a plus n1 by a, by all these things. But all these things I already calculate here for somewhere. It's say maybe I did a mistake. I don't know, m2 minus n1 divided by n1 plus m2 by g is 90 divided by 110, 90 divided by 11, 90 divided by 11 by 10 by g. So it's 81.8. The acceleration or what? 90, oh no. It's 90 divided 0.8 by 10 is 8.8, is correct. Is correct, so this is the acceleration, so it's easy. So this is the tension. So review the problem. Maybe I made a mistake, but I don't think T equal m1 by a plus m1 by g, m1 10, m1 10 by 10, 100. No, I think I did it correctly. It's 181. So you redo it and you practice. Let's go to the next one. So we did this. So this one I'm going to leave you for you, only for you. You have to arrive to this equation. These two equations, they are exactly the same thing. The only thing is that now the motion takes place in this direction. Let's go to make this direction, this one, this direction. You make the positive x direction, maybe put it like this. So the object is, the system is moving like this. So this is your positive direction. So when you apply the equation for n1, the equation will be, the tension will be positive, T, minus the weight, the component of the weight is mg sine of theta, it will be negative. And this will be the mass m, little m, or m1, it's say m1, by the acceleration. We suppose that the acceleration a1 and a2 are the same because they are linked by the rope. So they move with the same acceleration. So this is the first equation. M1 cosine of theta of 1g sine of theta, perfect, T1, perfect. So for M2, I see the tension here, and I see the weight here, M2G. So the equation 2 will be M2G going downwards minus T going upwards equal M2A. Wow. Now I have to find the acceleration. Well, if I sum 1 with 2, the tension will disappear. Summing equation 1 with 2, the tension will disappear and will stay M2G minus N1G sine of theta equal N1 plus M2 by A. Oh, is that the problem? The A is this one. N1 sine of theta. You see, that is the negative of this result. It doesn't matter. You have to plug in the numbers to see in what direction they will move. If you put more mass here than here, the motion will take place in this direction. If you put more mass here than here, the motion will take in the opposite direction. So this equation is correct. Even if the result they say n1 sine of theta, it say the negative of this one, this result is also correct. It's when you plug in the numbers that makes you to feel correct. So maybe this problem was done supposing that the x positive direction was this one. X positive direction was this one. So you have to redo the equations with this new x positive direction, and for sure you will obtain this equation. And for the t, you solve the system of two equations with. Okay, so this is the problem. You do it. Clearly you can do it. This is what we saw with friction. With friction, we saw that there is a coefficient of friction that is static. Static means that the object still have not moved, so you apply a small force and the friction force is equal to the applied force. Later on you apply a stronger force, a bigger force, and the friction is equal but opposite sign. F of friction is opposite side to the applied force. So the acceleration is zero, so there is no motion. So there is a friction force. And the force of friction is mu by the normal. The magnitude of the friction force is mu by the normal. So this magnitude is mu by the normal. The normal in this case is mg, but not always the normal is mg, not in always case. So it arrives at a critical point, a critical value for the f, when the object starts to move, and the coefficient that here is static become dynamic, and the mu dynamic is smaller than the coefficient of friction is static, and the object starts to move, and this figure represents the force applied. This represents the force applied, and you see the friction goes smaller when the force overpass a critical value. For this critical value, the friction becomes a smaller friction. Negative, going to the left, but smaller. Okay, so this is the friction force dynamic, while this is the friction force static. So this is what you need to know. Basically, what we have to do is to solve this problem. This problem we have solved in class. I think we have solved in class, but we review it. Okay. it say, equal to C. So, what we have seen. The first example say a body starts from rest, mass m, the mass is m, you don't need to know the mass. So it goes 3 meters going downwards, and it say find the magnitude of the velocity at the bottom of the inclined plane. Well, at the bottom of the inclined plane, the only force that is pushing the object downwards is g sine of theta. This is the acceleration. This is the acceleration that is pushing. The force is m by a, mg sine of theta. But the acceleration is g sine of theta. So if I know the acceleration in the x prime direction, I can use the equation that I have proved also in class, that bx prime squared minus v0 x prime squared is 2 times the acceleration in the direction x prime by the multiply by the displacement in the x prime direction. Because it says that it starts from rest, v0 is 0, so v squared is 2g sine of theta by delta x. So when it arrives, when the displacement is 3 meters, sine of theta is 1/2, v squared is square root of 30, let me see, 20, 60 divided by 2, 30. So the velocity when it arrives to the edge of the inclined plane is the square root of 30. Now, the real problem now is to do the same thing when there is a coefficient, a dynamic coefficient of friction, 0.3. Find v when it arrives to the floor of the initial plane. So if it's dynamic, the problem, the object have a 0.0001. It starts from rest, but it starts just when the force is bigger than the static friction force. So it has this force, mg sine of theta, so let's go to do it. The question here is to find the acceleration. If we find the acceleration, we are done. Now, let's go to find the acceleration. So this is the body, this is the body. Okay, this is the weight, mg. This is the component of the weight that the force, the component of the force that is pulling the object downwards, mg sine of theta. This is theta. Okay, and there is a friction force. This is the force of friction. So we choose a positive direction. Let's choose this positive direction. So the sum of all the forces on the x prime direction equal the mass by the acceleration on the x prime direction. What is the sum of all the forces? I see mg sine of theta going downwards, positive. And I see the force of friction going upwards. And this should be equal the mass by the acceleration. So my question is, what is this acceleration? If I find this acceleration, I will use again this equation, and the problem will be solved. So mg sine of theta minus the friction force. But the force of friction, we said that the force of friction is mu by the normal. And in this case, the normal is not mg cos mg. The normal is mg cosine of theta. So you have to do, again, Newton's law equation apply to the y prime axis. So this is the y prime axis. This is the y prime axis. So there is no acceleration on the y prime axis because the object is moving exactly on the x prime axis, is parallel to the plane. So ay prime is 0. So what is the sum of all the forces on the y prime axis? Well, mass by acceleration, but I said that the acceleration is 0, so mass by acceleration will be 0. So what is the sum of all the forces on the y prime axis? On the y prime axis, I see the normal force going upward, and I see this component of the weight. So I see mg cosine of theta going downwards, this one. mg cosine of theta. And I see n going upward. If you prefer, you choose the y prime direction positive in this direction, and you will write minus mg cosine of theta negative equal mass by acceleration 0. In both cases, you will obtain that the normal is mg cosine of theta. So this is the normal that I have to use here on this equation. So it's mu dynamic by the normal. The normal is mg cosine of theta. And this is equal to mass by acceleration. So what happened here? Well, this is the mass by the acceleration that we want to find. So I hope I didn't make a mistake during the class. The mass, I think, is 2 kilograms. Let me see. The mass is m. No, the mass is m. There is the mass is m. So, but it doesn't matter. The mass is m, but the mass will cancel on this equation. So the mass is cancelled in this equation, so you don't need the mass to find the acceleration. So ax prime will be g sine of theta minus mu g cosine of theta. Perfect. I know g, I know mu, I know theta, I know a prime of x. So find a prime of x. It will be, well, you do it 10 by 1/2 sine of 30 minus mu. I don't remember what it says. It says 0.3 by 10 by cosine of 30 square root of 3 divided by 2. You find a prime x. So the velocity v squared final minus the initial velocity will be 2 times ax prime. It is supposed by delta x prime. So the velocity v final, v squared, will be 2 times this a that you will find, this a, by the displacement delta x prime that say 3 meters. You multiply and you find the velocity square. Okay, let me see. See, we have solved in class because these are the notes for the class. I think that that's all. Let me see. This is what we have done during the class. I don't know why I did so many things. Okay, this is the calculation that I did. Okay, review of it to see if I made a mistake. I said at the end that when there is no friction, the velocity is square root of 30. And now that there is friction, the velocity is smaller. It's normal. It's less acceleration. Okay, that's all. Okay, and this just to review, this was using the equation of motion for constant acceleration for displacement, delta x. This is displacement. X minus x0 is the total displacement. And using the equation for velocity of a motion of constant acceleration, v equal v0, solving for t on this equation, and plugging this t here and here, we work with this, and at the end we obtain this equation, v squared minus v0 squared equal 2 times ax by delta x. This is a useful equation that relates the velocity not with the time, with the displacement and with the acceleration. So the square of the velocity is related with the acceleration of the object and the displacement. You see, the acceleration have units of meters per second square, and the displacement have unit of meter. So this will be meter square per second square, and the velocity has also unit of meter square per second square. So this equation, dimensionally speaking, is correct. Okay, that's all.